In this video, we shall start reviewing measures of spread of data. As you might recall, in earlier videos, we talked about measures of center for a single numerical variable, namely the mean, the median, or the mode. But in this case, we want to see how to measure how data values are spread around the measure of center. Mostly, we use the mean as the measure of center if your data set is symmetric and unimodal with no extreme outliers. Because we know that when we have extreme outliers, median is the better measure of center. So, the different measures of spread that will be of interest here would be led by the standard deviation, which is the most common measure of spread. You see, let's say we have the numbers 1, 2, 4, 5 from a larger population, and we'd like to look at the range. The range is simply the biggest number minus the minimum. That would be 5 minus 1. So 5 minus 1, that gives us 4. Done. But what about the standard deviation? What about the variance? Let us see how to do that. To compute the standard deviation, we need to compute a measure of center, namely the mean, which we'll denote as x bar. So that will be computed by adding 1 plus 2 plus 4 plus 5 divided by 4. So that will be 12 over 4, that's equal to 3. So 3 is the kind of center value for all of these values. Well, what is the measure of spread that we're trying to compute? That is the standard deviation. In other words, on average, each of 1, 2, 4, and 5 are all deviated away from 3. But on average, what is the average deviation of each of these values away from the mean value, the average typical center value? To measure that, we use the standard deviation. So to begin with, we say, how far is 1 from 3? That's negative 2. How far is 2 from 3? Negative 1. How far is 4 from 3? 1. How far is 5 from 3? 2. You might notice that some of these numbers are negative, some are positive. We don't usually like that in statistics, so we're going to bring them to the same scale by squaring each of them, which would necessitate or give rise to only positive numbers. So you have negative 1 squared, you have 1, you have 1 squared, you have 1, you have 2 squared, you have what? 4. Now, these are all the deviation squared values. If you bring up calculate the sum of all of these numbers, and you divide by how many numbers did we have originally? 4 values. So I'm going to say 4 minus 1. We usually take away the 1 to complement something called the unbiasedness of an estimator. And in this case, you take the square root. What you have is the standard deviation. So in this case, standard deviation is equal to the square root of the squared deviations, the sum of all the square deviation divided by the sample size minus 1. This is called, in particular, the sample standard deviation, represented by lowercase s. So this will be the square root of the result of 10 divided by 3, which will give us 1.8257. This would be the standard deviation. And to find the last one, which is the variance. The variance and standard deviation are closely related. So the standard deviation here is right there. And the variance is simply the value whose square root we took, which is 10 over 3. Or it is the standard deviation what? Squared. And so that is provided. In a nutshell, the variance is the average squared distance from the mean, whereas the square of the standard deviation can also be regarded as the variance. These are two ways we can see it. Let me write that out very well. Variance. Very good. So the standard deviation is always the square root of the variance. This is going to be very useful for us as we proceed. Now, I want to distinguish between the sample standard deviation and this is the population standard deviation. We always use the sample standard deviation by default unless we are told that the data represents population data. So to illustrate how to compute standard deviation in StatCrunch, we're going to look at a random sample of 20 pledges to a public radio fundraiser which revealed the dollar pledges in the dataset pledges. And we are to complete the question below. We would like to find the range, the sample variance, the mean, the sample standard deviation, the coefficient of variation, the first quartile, the third quartile, and the interquartile range. Okay, to get started, let's navigate to StatCrunch. Let me pull that up. And in StatCrunch, I have the values on the pledge amounts. My interest is to compute some summary statistics for these data values. So I'll go to Stats, I'll go to Summary Statistics for data in a column and click on Columns. And I'm going to select Pledges, of course, so select Pledges. My interest, according to the question, is to get the range. For the range, that's easy to get if I have the maximum and the minimum values. So I'm going to also compute that in the process. So I'm going back here. I'm going to indicate that I want the mean. I want the variance. Let me start with this. And then hold down the control key, variance. I want the standard deviation. I would like to get the range. I would also like to drag this down, get the first quartile, the third quartile. I like to get the interquartile range and the coefficient of variation. And if I like, even the mode. But for now, let me compute that. So I have all the summary statistics here. So uh, for the range, I have 105, which is computed as 130 minus 25. So all of the values I want in the question, I have computed here in StatCrunch. Okay, and with that said, I can be able to proceed to question B, where I would like to look at the difference between the standard deviation and interquartile range as a measure of dispersion versus spread. Well, what I want to summarize here is depending on the distribution you have, if the distribution is unimodal, symmetric, and has no extreme outliers, I would like us to use for the measure of center, we should use the mean, and for the measure of spread, use the standard deviation. Then if it's otherwise a skewed distribution with some outliers, because of the impact of outliers on your measures, you should use the median as the measure of center. American spelling will be center that way. And then for the measure of spread, use the interquartile range. How can we use this? Well, here's question C. How should a data analyst report our findings to describe the distribution of dollar pledges? Well, that will depend on the characteristics of the distribution. So I'm going to draw a histogram and see what that distribution looks like, and then choose the appropriate measure of center and spread. Let's go back to StatCrunch. I'm going to close out of this, and I'm going to go back to pledges. And I'd like to graph a histogram of dollar pledges, and I would like to see where the median is. I'd like to see where the median mean is. This is very important, and I'm going to compute that. Okay, so I have this piece and this piece. Well, I can't see if there are any outliers. So another thing I'd like to do is I'd like to draw a box plot to see if I have any extreme outliers for pledge amounts. So pledge, and I would like to see the median, of course, as usual. And I'd like to grab and drag this up so that I can get to the compute button. And let me see, let's drag this up. I can't see any dots here, so I don't see any extreme outliers. This will pass as a very good symmetric distribution. So let me go back to my previous results. I'd like to look at the histogram again. Yep, there are no outliers, and this appears to be approximately symmetric. Not too many outliers here. So based off that, I don't have any extreme outliers. I am going to report the average or the mean as the typical dollar amount with a standard deviation of the value of the standard deviation. And to see those values, we can go back to StatCrunch, look at previous results, and I want to look at summary stats for pledges. Click on that. So I will report that the typical pledge amount is $74.50 with a standard deviation of $27.76. All right. So right in the context of this, take note that the mean and interquartile range are associated with skew distributions that might have potential outliers. And that is because both of them are robust statistics because extreme observations or outliers have little effect on their values. This is very crucial in noting why in statistics, the appropriate statistics to report for skew distributions is the median for the measure of center and the IQR for the measure of spread. Okay, now we want to look at what the stem and leaf graphs. Well, this is another representation for numerical variables, but they are very useful when the data sets are small. In this case, whenever I look at the stem and leaf plot, the stem is right here and the leaf is right here. So we can tell that when you see, if I were to convert this representation back to raw data, the raw data will be 4 by 4 represents 44, the raw value 44. So 4 by 4 here means the first value here is 44. The second value is 4 and 6. The third one is 4 and 7. So the stem, which is 4 in this case, pairs with every number in the leaf. So, and the last one here is 49. There was no 50 something. Then you had 63 next, then next 64, and so on. Remember, an outlier is an observation that appears extreme relative to the rest of the data, and sometimes it is called an extreme value. Here's an example of raw data that we would like to look at from the scratch. So if we are to create a stem and leaf graph, I might need to develop a reasonable key. This is what will guide my thought process in the choice of a good key. I am going to look at the fact that I have 1.1 to 12.3. So I'm going to use every number before the decimal as my stem. And I'm going to use numbers after the decimal as my leaf. So in which case, I'm saying 1 bar 1 will be representing 1.1. So I have 1 here, 1, 1, oh, excuse me, that'll be 2. So I have 1 against 1, then 1 again against what? 5. Then we have 2, 3, that is this guy, 2, 3. And then 2, 5, 2.5 is 2, 5, 7. And then 3.2, so we have 3.2, 3.3, 3.3, 3.5, 3.7. Next we have 4.0, so 4.0, 4.2, 4.5, 4.5, 4.7, 4.8, 5.5, 5.6, then we have 6.5, 6.7, then it jumps to 12. We're not allowed to skip every other number, so in this case, I'm going to put my 7 here. I don't know why I did that. So you have 7, 8, 9, 10, 11, 12. So this is 12.3. If I were to draw bars on top of this, does this remind you of something? This looks like a histogram for small data sets. And I can readily tell that this seems to be right skewed with some outliers, where we have concentration of values in about this axis.